Hello, one. So we have another AIME problem. So this was a trig identity, and I will use a number theory a bit to finalize the question. So it says find the smallest positive integer solution to this equation. So let's see what we are given. Maybe there are some hints in the problem itself. So on the left side, we have tangent, and the right side, we have cosine and sine as added together and subtracted. Like, okay, so it's not really obvious, but just remember, we have angle sum for tangent, right? So if I kind of remember that, so that looks like tangent of A plus B was tangent A times tan B over 1 minus tan A times tan B. So if you do remember how we drive this in the first place by using angle sum of sine and cosine, so you can get this on your own as well. But if you don't know, just please try that on your own because that's important for us to know how to get these. Otherwise, we should just memorize, which doesn't really help usually. So this is the tangent angle sum identity, right? But we have on the right side, not tangent. So maybe we can try converting this right side into tangent. So because if you know tangent something equals tangent something, you can compare their angles, right? So that might be easier. So our goal is just to make the right side as tangent. So since we have a fraction, I'm just thinking about maybe you can use angle sum for 10, but there is no 10. So what we can do, like I can divide the numerator by cosine 96. Why is that? Because if I divide by cosine 96, this will be 1. This will be sine over cosine, which is going to be tangent. So it will be similar to this one a bit. So let's go ahead and do that because I can't play favorites, so I should divide by numerator by that as well. So the cosine 96. So if I divide cosine 96 by cosine 96, that is just 1. And sine 96 divided by cosine 96 is just the tangent 96. This is going to be divided by cosine divided by cosine is 1 minus sine divided by cosine is tangent. Okay, so this is good so far, right? This is 96, this is 96, and this was tangent 19x degrees, but I'm going to ignore for now, but we know this is degrees. Okay, so this is almost similar to this one, but it's not exactly because there is like 10a, but that's 1. Maybe we can write the value of this one because that's equal to tangent 45. So tan 45 plus tan 96. And this is divided by 1 minus, like this is 1, so I can just write 1 times tangent. I don't know why I had to 8, but okay, that's going to be tan 45 times tan 96. Okay, so now this is exactly in this form. So we have tangent of 45 plus tangent of 96. So 45 and 96 are my angles. And now we have 1 minus and product of those two angles. So that means the right side is the same as tangent of 45 plus 96. Okay, so the left side was tangent 19x. So if I clean this a bit, so that should be tangent of 141. And that is equal to tangent 19x. So if you were able to get till this point and stuck right here, it is all good because whatever we did so far was about using the angle like trig identities. But after this, if you cannot finish the problem, then it's okay because we do have a bit number theory involved, okay? So the first things first, you can say tangent like 19x is equal to 141. So the angle right here might be same as this one, but if they are equal to each other, their tangent values are equal. But if you make them equal to each other, you get x is not integer. So which is we do our like we do look for a integer solution, so that doesn't work. So but at the same time, tangent is a periodic function as other functions, and the period of the tangent function is like pi radian or 180 degrees, meaning that whenever you add some multiple of 180 degrees to this number, so that should be the same as 19x. So we can just say 19x is equal to 141 plus 180 times n, some multiple, and then your goal is to get some number n that will satisfy this equation that will give us x to be integer. You can kind of brute force, you can try plug in some values until you get the one that is correct, but it will take forever in some cases, especially in this one as well. So which is why we do need some other tools to handle this situation. So if you know the Euclidean algorithm, you can try using the Euclidean algorithm, which is also easier to try. But instead, I'm going to use the congruency. So what I mean by that, I'm going to write that equation, so 19x, and then make it congruency, which will give you 19x is congruent to 141 plus 180 times n. But I'm going to take the mod 180. So if you are confused right now, then I will ask you to review the modular arithmetic a bit. What I just did basically, I take the mod 180 of this equation. So what does that mean? We are going to divide the numbers by 180, and then their remainder or residues will be congruent to their value, okay? So if that's confusing, then you really need to look at it. But this is AIME problem. I'm hoping you already know these already, okay? So if I take mod 180, so this 180 will be 0. So that's the point that we are taking the mod 180 to cancel that variable. And the left side we have 19x is congruent to 141. Okay, so plus 0 times n, so that is mod 180. Okay, so this is gone, that's okay, but how do I still get the x alone? Because there's a number in front. And if you like try using the inverse of the congruent, like inverse of the numbers with the congruency, then you can try that. But just remember 19 squared is 361, which like is one more than the twice of the 180, which is we are taking the mod of. Then maybe that is useful. So if I multiply the both sides of this congruency by 19, you will get 19 times 19 times x is congruent to 19 times 141. And that is mod 180. So if you multiply these two, before we do this, let's do this first. If you multiply these two, you got 361. And when you divide by 180, you get a remainder of 1. So that's going to be congruent to this product. So that's just going to be 1x is congruent to, if you multiply these two numbers, I will get 2679. So let me double check. Yes, that is 2679 and mod 180. So if you divide 2679 by 180, and then you're going to get the remainder, which is going to be congruent to this guy. So the left side is x is congruent to 159 mod 180. So it's telling us x could be 159 or some addition of multiple of 180s. Like if you add 180 to 159, you get another integer of x. If you add 2 times 180, you get another. And whatever you add as multiple of 180 to 159, you get another integer solution. Since we are interested in finding the smallest one, so that is 159. So I hope that makes sense. We just combine the modular arithmetic and trig identities together. So that was the question. Okay, I'll see you in the next video.